Hi, I'm Steve Hosher with RazorGage. A lot of times people ask us what's the difference between our competition and us. So I'm going to do a short video about those differences. Our premise is that for a stop to have a return on investment, it has to be reliable and accurate every day. If you have to check the parts after you cut them, you really haven't gained that much. So in order to get a return on your investment, the parts have to remain accurate day after day after day. The second part of that is that most stops calculate the linear position based on rotation of the motor. There's an encoder on the back of the motor that the controller counts pulses so that we calculate the linear position. In order for the linear position to be accurate, the components between that encoder and the stop that you put your material against have to be precise. So let's start with the stop itself. The stop is mounted to a carriage on which two linear bearings like this are mounted. Our competition uses an extrusion within an extrusion and uses plastic pads to ride on the aluminum inside the beam. Aluminum extrusions are never straight or true, so it makes a poor bearing surface. What we use is a high wind linear bearing, hardened and ground steel ways with recirculating balls inside this block. These have virtually no play in them at all. These are the kind of bearings you'll see on high-end precision CNC routers and machining centers. Our RazorGage ST uses two of these blocks on one rail. You can see the width of the carriage. There are two blocks inside here. Each block is rated for 2,000 pounds of load, so we have a very rigid carriage that has consistent linear motion throughout the stroke. The next thing we do, attached to the carriage, is the belt. If the belt stretches or breaks, of course, you're not going to get good parts. Our microprocessor that's in our controller is dedicated to watching that encoder I talked about earlier to determine if the stop or the motor has encountered an immovable object. So it kills the motor immediately upon impact. That's why we don't stretch belts or break belts. Therefore, we always have good accuracy with the belt. The belt goes from the carriage and wraps around the drive pulley. The drive pulley is mounted to a gearbox on the motor. We have these drive pulleys specially machined so that there is zero clearance between the teeth on the belt and the teeth on the pulley. So we have no backlash with the pulley and the belt. Standard pulleys have a 1/64 of an inch of backlash. Any backlash that occurs between the belt and the pulley is variation you'll see in your parts. The drive pulley is mounted to the gearbox. We use a planetary gearhead. This is the same kind of gearhead you'll see on high-end machining centers and machine tools. The planetary gearhead has a sun gear and 3 planet gears around it, so you always have 3 teeth at least engaged in the pinion gear. Our competition uses a simple spur gearbox that's prone for backlash. So mechanically, our components are very sound from the motor all the way through to the carriage. So, by minimizing backlash throughout the whole system, we're able to maintain accuracy. And that's the difference mechanically between RazorGage and the competition. Thanks a lot.